effect size. We all know null means no effect. Alternative, there is effect. So we've seen the word effect before. And the objective of statistics I guess we'll have to play the word games. Okay, 12 letters. You can do it. Start with the letter S. Very good. Statistical significance. So you guys are getting better. What is that game? I forget. Yeah, there are memes.
Amen.
Huh?
Amen.
What?
Amen.
Hang on. No, it's a TV show. You know, you guess
Wheel of
word.
Fortune?
Huh? I think it's Wheel of Fortune. Hang on. I don't even know that. Our goal is to establish statistical significance, in other words. We are going to determine, is the observed effect statistically significant? That is the point of doing statistical testing. When do we say that there is an effect? When we reject the norm and find evidence to support the alternative. But there is an issue in establishing statistical significance. Later on, when we get to the formula, I'm not sure if your book is going to do the formula and stuff. Again, I take this book because it's not math heavy. Last semester, last couple of semesters, our book was math heavy. I didn't this semester. We will see what happens when we get to it. But I will mention an issue with statistical testing. But caution. Issues to consider. One thing that people would always say is if you have a large sample size, then you have better conclusions. You would have heard this before. Yes, in real life, even a regular article might say, oh, we sampled a huge population, got a big sample, so our test, our conclusions are relatively bad. There is a problem. The test formulas depend on sample size. A large sample size with little to no effect might be concluded as statistically significant. little to no effects. Common sense. If I look at something and I see the effect to be not that great, and I do a test and I repeat it multiple times, get a really large sample size. The test that I do, I actually conclude that I'm statistically significant. When common sense tells you whatever that you're observing, it's not that big. Okay? So that is a problem. Do you agree? When you look at something, things seem to be very close, but you just repeat the experiment or study and make the sample size larger. All of a sudden, you conclude it is statistically significant. That's what a test would do. That is a problem. Question? Statistical significance is only reliable based on assumptions. You violate them, and then you conclude, oh, it's still significant, in line field. So assumptions are required. Going back to chapter 4, we started with a null distribution, also known as reference, very good, also known as comparison. We assume something, so if that's violated, then no matter what your test concludes in terms of significance, it's not good. So people use this phrase, statistical significance does not always indicate or imply practical significance. That doesn't mean you shouldn't do statistical tests. What I'm saying is you've got to do it right. And even when there are times where you establish statistical significance, stop, use a bit of common sense and ask yourself, is this making sense? There are ways to address effect size. One of the examples is Cohen's t. We will do that, I believe your book covers it. After I show the simulation, if we have time, we can go over that as well. Every test will have a way to assess practical significance. Does that have issues? Yes, it does. Because just like alpha, where we pick conventional levels, practical assessment of practical significance for a given test has dimensional levels. So it could get a bit subjective. Good. So we pick alpha as 0.05, 0.01, 0.1. Currently, I will summarize this later. In terms of effect, we will have 0.02, 0.5, 0.2, 0.8. And those are based on experiments also. So that's not perfect either. But what we have to understand is we are dealing with random stuff. So we have to accommodate a lot. Typically, when we assess practical significance, once you establish that there is statistical significance, then you ask the question that the significant effect that you have noticed is also practically significant. Good. You don't jump directly to this. You do that first, and then just to reassure yourself, you'll do that. Good. Okay. Here is the